So apparently I upset some people. I think it's important today that I address the accusations that have been levied against me. And it's caused a lot of turmoil. And so a lot of you know that last week I posted a critique of a paper. And some things that I said in that video were very upsetting to some people.
Why do you always comment on methodological issues and suggest other methods when you have no idea about the method used in the paper in the first place? Stop criticizing the hard work of scientists in this absurd fashion before you even understand them. I hope you don't ever get any papers for peer review because this standard is simply horrible. I think this attitude of apparently correcting the work of other researchers is a thing I find issue with. If you're serious about the research and not just looking for views, write a commentary like everyone else. But far be it from me to remind a YouTuber of ethical responsibility.
And in retrospect, the words that I used, the rhetoric, I guess I could have chosen my words more carefully. And I think it's really important for me to just not shy away from what I need to do. I need to own up to it. And so with that in mind, let's watch the video about what I said. And what they ended up doing was something that I'd never heard of. What did they call it? They used a fixed effects regression specification. I don't think that's the best way to do things. I would do a mixed models approach. So instead of subtracting everybody's own cluster mean and then setting everybody to have an equal cluster, instead of doing that, what we would do is we would just model the individual cluster slopes, and that would be just a better way of doing it. And so when you do this approach, you can't estimate random slopes. You can't estimate everybody's own individual trajectory, which seems problematic to me. I totally forgot to give a trigger warning about that one, and I forgot to warn you to shield your children's ears because what I said was so offensive. Apparently, that's how you start a holy war among quantitative nerds. So yeah, I made some econometricians angry. Very angry, it seems. And apparently, if you suggest a mixed model to an econometrician, in some states, it's a capital offense. So I've been told. Now, to be fair, they were not entirely wrong. And normally, when I read comments such as that, I just ignore them. Except the problem was, some of the words that he said made me wonder if there was something that I could learn from what this individual was saying. And yes, there is. Because here's the thing, there are different cultures among different quantitative specialties. And those who are in economics, they have their own culture. It's kind of interesting. Out of all the different stats-related subdisciplines, I think economists are the most unique. And with that uniqueness comes a unique culture. See, the thing is, economists live in an observational world. If you're trying to evaluate certain factors that play a role in the economy, it's not like you could set up an experiment and then manipulate the economy. You can't randomly assign recessions or political parties or anything like that. But the problem is, in science, we often want to establish causation. How do you establish causation without being able to manipulate your environment? Well, in those situations, you can't run an experiment, obviously, and instead what you do is you place further restrictions on your data analysis than most other statistical procedures have. And the enemy, or the key assumption and the enemy of any econometrician is what's called endogeneity. And essentially, they're just hidden and unmeasured factors that really screw things up in your analysis. And it makes a devil of a time when you're trying to infer causation. So that's the econometrics mindset. And the other mindset is the rest of us. I don't know. So like a statistician or a quantitative psychologist like me or a biostatistician, I've had experience playing all three roles. We generally don't use statistics to handle causation, with some exceptions, like the Pearl framework, which I'm not going to go into. But most of the time, if we care about causality, we'll do experiments. Simple. Because we're not dealing with economies and recessions and whatnot. And so causation isn't really a big concern for us. And so even if we're using non-causal like models, we usually don't really care about causality. We care about variance and fitting models and trying to explain what's going on in our data. And to come up with plausible hypotheses that may or may not be causal. And if they are attempting to be causal, we always hedge it and say, I know, this is just an observational study, so we can't really believe the causality they're in. But close enough. So while the economists care about endogeneity problems, we really don't. We care about noise. We just want models that fit well. And so what the economists would like to do is they would like to eliminate, statistically speaking, individual differences. Whereas when we're using mixed models, which I'll talk about in a minute, we want to model those differences. So now, let me go back to the model that these authors were using. It was a fixed effects regression model. And last time I kind of sped through the explanation, so I'm going to take a little more time explaining it this time, with some fun animations. Yay! So the model looks like this. So we got YIT is equal to beta times XIT plus AIT plus EIT, or epsilon IT, where YIT is the outcome for person I at time t, XIT is the predictor for that person at that time, and the subscripts are getting annoying, so I'm just not going to say them anymore. And then A represents person-specific intercept. So that captures all stable characteristics about a person. And then epsilon is the error. So it says that every person has their own unique characteristics, A. And those A's are what we're trying to get rid of. We don't like them. Because they create this endogeneity problem that makes it difficult to infer causation. But notice the B. It has no subscripts. It is the slope, and it is the same for every single person. So let's say we want to estimate B, or the slope. But we have this problem. We've got this A variable, the individual characteristics. And those are very likely correlated with the predictor variable, or X. That right there is the endogeneity problem. If A and X are correlated, then we're going to get biased estimates of B, or beta, whatever you want to call it. Technically beta. I should probably be precise in my language because people are already attacking me. So the economists came up with a clever hack that's basically a transformation. So what we do is we take this model and then we estimate each individual's mean, both for the outcome and X. And let's say X is time, just for fun. So what we're going to do is we're going to take each individual's mean and compute the average across time. And that applies for both Y and X here. So now what we want to do is we want to take that earlier model and estimate the differences instead of the actual Y values. And so we go Y minus Y bar is equal to beta times X minus X bar plus A minus A. Oh, you can probably see where this is going. Plus E minus E. And then once we simplify things, we get rid of the A's. So what happens is when we subtract the mean, this A value disappears. And now we can run ordinary least squares using the de-meaned, like unmeaned or meanless values. So this will give you an unbiased estimate of the slope, even if you have major differences on A. And even if A is correlated with X. A is gone now. So let's think about this conceptually. What it's saying is that every person becomes their own control, which you can do when you have repeated measures. That's kind of nice. But by doing that, every person is now centered in the same place. So even if one person had a score of 15, another person had a score of 2, now they have been equated. And I think that will be easier to see if we look at a visual. So here we have a repeated measures data set where we are looking at vaccination intentions over time. And if we are just to plot the data set as is with a different color for each person, we can see that every individual has their own trajectory, but they also have their own mean value on the outcome. But what we do with fixed effect regressions is we do some computations before we actually plot it. So let's go ahead and zoom in on person A and see what that looks like. So we start by creating 2 new columns, one which represents the mean of time and the other which represents the mean of vaccination intentions. And then for each individual, what we're going to do is we are going to compute their average on both of those variables. So for time, it's going to be 3, but that's going to be the same for every person because everybody was measured at the same intervals. But their vaccine intentions are going to change. So for person 1, their vaccine intentions is averaging 10.5. And for person 2, it's going to be 12.9. And person 3, it's going to be 17. Now what we're going to do is we're going to take their raw time scores and their raw vaccine intention scores and then subtract the mean from each of those. So we get something that looks like this. And the important thing to point out here is that because you are subtracting each individual's mean from their scores, the sum of those is going to be 0. So on average, everybody has identical vaccine intention scores. And then when we plot those, what we see is that every individual still has their own trajectory like they did before, but now all those scores tend to be clustered at the same value, which is going to be y is equal to 0. So that's what these models do. They maintain the trajectory over time, but they eliminate between person differences. And that ability to get rid of A, that's why econometricians love these models, which is cool. It automatically controls for unmodeled, stable confounders. And I say stable, meaning they can't change over time, otherwise this process doesn't work. And so it's great if your interest is in causation. So that's the biggest advantage, is it handles the endogeneity problem. Yay! And for them, that's super important. But it does come with a lot of cons, and this is what I was trying to say last time. You lose any between-person characteristics. Because again, you're setting everybody to be at the same level, and so now you can't make comparisons between people. And maybe you don't care about that. Okay. But there's another problem. These models, these specific models, the fixed effects models, assume that everybody's slope is exactly the same. That's a pretty big limitation. And in the study that I critiqued last time, what that would mean is that people's intentions to take the COVID vaccine, every single person will have the exact same change over time, unless you specifically add an interaction effect, in which case you can do one for Democrats versus Republicans, which is what the authors did, but it's still assuming every single Democrat is going to have the same slope over time, and every single Republican is going to have the same slope over time, which doesn't sound realistic to me. Another problem is that you can't estimate the main effects of any of these stable characteristics. And this is a major problem for that particular study. Because one of the questions they wanted to know is, are there differences in intentions to vaccinate for Democrats versus Republicans? They could not estimate this with fixed effect regressions. And it makes sense because, again, you're equating everyone. Everyone has the same average score. And if everybody's equated, there's no way to compute differences between these stable characteristics. So one of the very purposes that they were trying to do in their study, they could not do with that particular model. So they ended up doing a t-test once at every time point, which is another issue that I didn't have time to complain about last time, but I'll complain about it now. And so they did a bunch of t-tests, one for every time wave to see if there were differences between Democrats and Republicans. And in a separate model, they used these fixed effect regressions, where they were able to estimate differences in trajectories between Democrats and Republicans. And I'm not going to go into why you can estimate an interaction, but not a main effect, but you can. And so in order to evaluate the research questions, they had to use two different types of models. But if you did mixed models, you'd only have to run one model. Just saying. A fourth limitation is it doesn't handle missing data very well. Because the thing is, if you have missing data on any wave, so let's say you have an individual that did the first wave and the second wave, and then skip the rest. With these fixed effect regressions, there's not really an elegant way to handle that. Most of the time, they default to just deleting all the observations. So even though that person contributed 2 data points, you're getting rid of them entirely. To me, that's a big deal. To me, it is more important to avoid that problem than it is to infer causality. But again, that's because I'm coming from a different discipline. And just to make this even simpler, let's say we have 2 individuals, Bob and Alice. So let's say Bob starts at the mean and then goes up 2 points. And then maybe Alice starts well below the mean and goes up 2 points. A fixed effects model would say, I don't really care about Bob versus Alice and where they started. All I care about is that they have the same change. Okay, that's fine. Whereas a mixed model would say, wait a minute, that's kind of interesting. But of course, the cost of a mixed model is that you now have the endogeneity problem to worry about. So as I said, I prefer mixed models. It doesn't have any of those limitations. And what it does is it models both the between effects and the within effects. It can estimate random slopes. It can model stable person level characteristics. And it handles missing data very cleanly. But again, the problem is that it assumes that there is no correlation between any unmeasured/unobserved characteristics and the variables included in your model. And if they are correlated, then you're going to get biased estimates. So basically, econometricians would rather throw away data than risk bias. And that's okay. That's understandable. Whereas statisticians would rather risk bias than throw away information, including variance estimates. So they're just different priorities. And like I showed at the beginning of the video, it was a very mild critique. And I even noted the advantages of the models. And that was really a minor point. The bigger point was the more egregious things they did, like doing median splits and auditioning predictor variables using like 30 different regression models. And interestingly, nobody yelled at me for those critiques, just for suggesting a mixed model. So my apologies to the econometricians for having different values than you. How dare I? And I thought it would be interesting for this video to just compare side by side my approach versus their approach. Why not? So let's start with some visuals, because I always start with visuals. So I'm going to look at the mixed model first. And when we do that, we get a plot that looks like this. And by the way, I'm using my cluster adjusted scatter plots that I invented a couple weeks ago to plot these, just because it makes it easier. And so what we see is we see two lines, one for Democrats and one for Republicans. The Democrats have a relatively flat line, or in other words, their intentions to vaccinate do not change as time progresses, whereas the Republicans certainly do. It's not a huge negative slope, but it is a slope. But importantly, we can see the mean differences between the Democrats and the Republicans. We have a vertical shift, or another way you can think of it is they have different intercepts. Now let's contrast that with the fixed effects regression model. So if I were to plot that model, it would look like this. And the first thing that we notice is now there are no intercept differences. If you average across the waves, they end up having the same values, which they should, because we have eliminated group differences in order to get this unbiased estimate. And notice we see something very similar to what we saw before. We see that the Democrats have a flat slope and the Republicans have a slightly negative slope. Now let's look at the estimates from the model. And the one that I'm going to focus on first is this one right here, which shows the average difference between Republicans and Democrats, which you cannot get with a fixed effects regression model. And what we see here is a value of negative 0.90. And by the way, I shifted all the wave scores to be -1, so the intercept is meaningful here. That tells you the average difference at baseline. So at the beginning of the survey, the Republicans had a lower intention to vaccinate by almost a full point on a 7-point Likert scale. So that's a pretty big difference, which is cool that we can know that because we're using mixed models. And you can't do that with fixed effects regression. But we also have some other interesting numbers that we could interpret, including the wave. So this number actually represents a 3.6 with the decimal shifted 6 places to the left. So basically it's practically 0. And just because of the way how dummy coding works, and I'm not going to go into an explanation of that right now, but that tells you what the slope is for the Democrats. So essentially, it is 0. Or in other words, the intentions to vaccinate for the Democrats did not change at all. And this right here, this interaction effect, actually represents the difference in slopes between Democrats and Republicans. But because the Democrats have essentially a slope of 0, we can just interpret this as the slope for the Republicans, which ends up being negative 0.118. So every month that passes, their intentions to vaccinate decrease by 0.118. So those are the mixed model estimates. Now let's look at the fixed effects regression estimates. First thing you will probably notice is there are no main effects here. It is just interaction effects. Because again, that's all it allows us to do. And this is telling us the slopes for the Democrats versus the Republicans. So the Democrats essentially have a 0 slope, or 0.002, which is essentially flat. Which is exactly what our mixed model was telling us. Now, what about the Republicans? Their slope is negative 0.115. And for the mixed model, it was negative 0.118. So they are practically identical. And we also have similar standard errors, and the conclusions that we would reach using the t-values to determine statistical significance would not change. Now, remember, the whole reason, the whole rationale for doing a fixed effects regression was because we were concerned about bias in the slopes. So if we are to assume that the fixed effects regression slope is unbiased, and if we compare it to the mixed model, that tells us that the mixed model is essentially unbiased as well. So the one advantage that fixed effects regression had going for it was that it would give us unbiased estimates. But if mixed models are doing that anyway, then there's no reason to use a fixed effects regression. Because with the mixed model, we can estimate main effects, and it's handling the missing data. And in general, it just gives us a whole lot more information than the fixed effects regression model is. So let me end with a comment about where I was wrong and where I was right. Where I was wrong, or at least short-sighted, is I wasn't considering the context of the original paper. Knowing what I know now, I would recognize that, hey, this is an econometrics sort of paper, and they really, really care about endogeneity. Of course, that probably wouldn't change much of what I'd say. I'd still say I prefer mixed models, but my purposes might be different. And where was I right? Well, I was right about all the limitations that I mentioned, such as how it handles missing data, the fact that it can't estimate stable characteristics, the fact that you can't compare baseline values, and the fact that it assumes everyone changes by the same amount. That's true. And so really, it's just a matter of priorities. So I would hope that reasonable minds could disagree without assuming ignorance or recklessness or bad faith. And here's my non-statistical take-home message from this. I welcome critique. In fact, sometimes I've been disappointed that people weren't more critical of what I had to do, especially when I'm going into areas that I'm just not familiar with. I want people to correct me. Yeah, I'm a bit terrified of saying something completely wrong and then having that information perpetuate. That would suck. So I would hope that people feel welcome to offer critiques. But the problem is when it's so inflammatory, I'm more likely to ignore it. In this case, there was a very valid criticism that was really overshadowed by inflammatory language. And honestly, I really don't care. If people hate my channel, they don't have to watch my channel. Watch another channel. I'm cool with that. But if you want me to respond, that's not a good way to do it. Because science thrives when people are willing to criticize one another. It's like a necessary component of science. But if we can't disagree with each other without being total assholes, I don't know, it's going to be hard to find somebody who listens to you. Alright, anyway, hey, if you want to learn more about mixed models, if you are in econometrics land and have seen the light of day, I'm just kidding, again, different priorities, but anyway. Yeah, if you want to take a mixed models class from me, I'm doing one in January. See the link in the description if you want to attend a live class taught by yours truly. And if you want to take an endogeneity econometrics class, you're out of luck. Can't help you there. But I don't know. Maybe I'll do it sometime in the future. Anyway, I hope you've had as much fun as I've had, and I'll see you next time. Peace out. Hey, look at that. I got a new backdrop. Woo!
What am I going to talk about?
What can I say? I am articulate and useful, all in one. No! That's always interesting when somebody asks me for a data set that I made up. Like, I want to write a research paper about this, man. It's really cool. Have you ever heard of a discipline called econometrics? Wow, I don't know a very nuanced sub-analysis within econometrics. I must not have really gotten a PhD because only somebody as dumb as carpet would ever say they don't know about those models. What is wrong with you, man?
I find my way to say today that I want to play.
Well, the problem with making videos at 11:55 p.m. I don't even have to finish that sentence. All right, well, I think we're good to go now. Let's go ahead and stop.